Okay. So an equation. An equation is always going to be something equals something. So that's kind of the Falk version of the truth. So something equals something. In other words, for an equation, you have to have an equal sign, and there has to be something on each side of the equal sign. So examples, you could say x equals 4. Or you could talk about the area of a rectangle, capital A equals area of a rectangle, length times width. So you could do something like that. Or, but each of those, they just have something equals something else. And you could just make up all kinds of weird, like 2x plus 17y minus pi equals, anybody something creative for the other side? 12. 0.2184697z. I don't know, but you just have to, write what you want. But basically you have to have an equals, and you have to have something on either side of it. Good for being an equation? Okay. So solving for a variable. Equations, a lot of books try to talk about them kind of like those pan balances, and I think it's my 8th grade math. I actually was on the ball enough, and I copy and pasted a picture from the internet, because if you look at this, it might make sense to you, but it might not. But do you guys use those things in science class where they're kind of like this here?
Oh, yeah.
And there's like a needle, and you can tell like which side's heavier? Okay. And an equation is kind of like one of these, where an equation is saying if it's equal, you know you have the same weight on both sides. So let's say I were to take and add weight to this side, then this side is going to go down, agreed?
Yeah.
Well, if I add something to this side, if I want to make it balanced, I have to do what to the other side?
Add the same amount.
Yep, I have to add the same amount to the other side, and then it'll go back to being balanced or being equal. Or if you were to do the opposite of that, say you take something away from this side, then that side's going to go up. To make it equal, you'd have to
Take something off the other side.
Perfect. Take something off the other side. And that's really what we're doing in this second part of the notes. That right here, I have an equation. It says it's equal. So I know that x plus 5 equals 9. Or x plus 5 is the same value, kind of the same weight as 9. Yes? But if I'm trying to figure out what x is, I want to be able to say x is some number. I have to get rid of the adding 5, right?
Mm-hmm.
How do I get rid of a plus 5 and keep it equal? Go for it.
Subtract 5.
Exactly. That if I take and subtract 5 from the left side, it's no longer equal anymore until I subtract 5 from the right side. And then what happens is my plus 5 and my minus 5 there cancel and just give me the x. And 9 minus 5 then equals 4. So in other words, x equals 4 is kind of the solution to the equation. It's what it equals. Oh, sure. I forgot I zoomed in a little. Does that subtracting 5 from both sides make sense? Okay. So up above in this part here, for an equation with a variable, so an equation like with this x, we look at what was done to the variable. So we had the variable and we added 5 to it right there. Agreed? So look at what was done to the variable, and then we do the...
Can I guess on
Go
that?
for it.
To do the same to both sides.
Not the same, because they added 5. We need to subtract 5. You might remember the word for that? It starts with an I. You can just shout it out if you know it. Inverse. So we were talking about inverses before that. Inverses, the inverse of adding is subtraction. The inverse of multiplying is dividing. So they added 5. We want to do the inverse. A lot of people, technically this is wrong, but you could think about it as the opposite. That's how I taught it for years. The opposite of adding 5 is to subtract 5. That makes more sense to a lot of people than to say inverse. But do the inverse to both sides. Because to keep it equal, if I subtract 5 from one side, make the balance 5 lighter on this side, I have to subtract 5 from the other side to keep it equal again. So if we do that for this next one, we had this x value. They subtracted 372, right? Look what was done to x. They subtracted 372. What's the inverse of subtracting 372?
Adding it.
Adding it. Perfect. So then we'll go and we'll add 372. But if I add 372 to the left side, I have to...
Add to the right side.
Perfect. Add it to the right side.
We learn it differently, but it gives you the same answer in some way.
Okay. I'll come back to you in a second on that one. So now this is going to be kind of a pain to do in your head. Shouldn't be that. It should be 128. Because we had that negative. Yep. So negative 244 plus 372 should be 128. So use your calculator. You can punch it in your calculator. Or what I did is I looked at it as though I had 372. Oops. So I had 372. And then my negative 244 is going to cancel out 244 of them. But you learn that more next year. So I wouldn't stress about it. Here's what I was trying to do, though. If we look at the first one. So I'm going to tell you guys a story about a friend named Dave. I was working. I used to teach Algebra 2. I had a guy, he was a sophomore, so he was in advanced math. Sophomore in Algebra 2, and he was barely passing the class. And so I told you about him? Maybe I don't know. But I mean, great guy. But I kind of had in my head, he's just not good at math. So we're working together after school, trying to get him caught up on stuff. He's just kind of lost in my class. And problems like this one here, he's doing this kind of stuff in his head faster than I can do. Yeah, just kind of like, what? So, okay. So for him, this was his problem. When he had ones like this, probably in 7th grade, he looked at X and said, well, what plus 5 is 9? 4. So he never learned to subtract 5 from both sides. He just, well, look at it, it's 4. You know, and then you get like harder ones like this. He still could do a lot of this stuff in his head because the dude was like off the charts smart. So he didn't learn he had to add 372, add 372. Soon we're going to start doing things like 5 times X equals 35. He'd look at it and say X has to be 7. And then he'd start getting things that said equals 37.5. And in his head he could say that X has to be 7 and... Nice try. 7.5. So the problem though is when he got to Algebra 2, now he was doing 5x minus 4, it's a 4, squared, I wouldn't, equals 32.5. And he couldn't any longer look at X and do it in his head. I don't think any normal person could look at X and tell you what the answer is. It's going to be some nasty decimal. So please, we're going to start, like today is just learn the steps for if it's X plus something or X minus something. Learn the steps. The next section will be another, like if it's multiplying or dividing. Learn the steps. The next section will be like when they multiply and add and subtract. So just learn the steps as you go. Don't rely on your brains to get you all the way to the answer, or when you get to things like this, you'll just be shut down and left behind. Good?
When do we learn that?
So you'll notice in these problems down here where it says show your work. So these here show your work. So say you have a problem that says something like x minus 17 equals 20. First thing I want you to do is just write out what the book gives you. Second thing, what do we do to both sides for that one? Add 17, add 17. So second thing is I'm looking for you to write what you do to both sides. And then third step, you'd say x equals 37. So I'm looking for 3 lines for problems like this when it says the show your work. So give me all 3 of those. And 25 to 51 looks like you don't have to, but if they're that same thing, then do it. So.